We're having echo. I'm gonna stop the output. Yeah. Let's stop the output first. Yeah, that should be good. I'll try again. Testing 1, 2, 3. No echo. Okay. Yeah. Good. Sorry. All right. Yeah, Heng Ji is a professor of computer science department of University of Illinois Urbana-Champaign. She's an Amazon scholar. She's the founding director of Amazon Illinois Center of AI for Interactive Conversational Experiences, AIC. She received her BA and MA in computational linguistics from Tsinghua University and her MS and PhD in computer science from New York University. Her research interest focuses on NLP, especially on multimedia, multilingual information extraction and knowledge enhanced LLMs. Some awards include Young Scientist by World Laureates Association, Young Scientist and a member of the Global Future Council on the Future of Computing by the World Economic Forum, World Women Leaders of Conversational AI, and AI's Pen to Watch award by IEEE Intelligent Systems. So as you can see, super distinguished, and I'll leave it to that.
Thank you. Can everyone hear me okay? Yeah, okay, cool. Thanks to all the organizers. This has been fascinating, and I'm feeling really, really honored. I was telling Ed that this is probably the peak of my career. So Ed is my dear mentor and more like my academic uncle. Ed has been, supporting and advising me throughout the career. I learned a lot from him, especially, we should hold a high standard and look into data, look into results, have deeper insights on research. And yeah, he was always recognizing my group's work, and my value when other people don't. So I'm really, really grateful. And yeah, so very happy to be here. This is actually a continued work based on some projects that Ed was a program manager at DARPA. So I'm very happy to brief the continued work and some recent results. Yeah, so this is a project called SmartBook. I would like to use this project as a use case to show what we can do that beyond what we can, get from OpenAI, right? And then, yeah, it's done by a bunch of PhD students and postdocs. Yeah. Okay. So let me just kind of start my talk by saying a few comments. And these are the comments I retrieved from a joint paper with Ed. It's going to be presented at EMLP as poster. It's about how we can define new playground for NLP. As you probably can see from all these previous talks, we are now living a really exciting time because it seems like, the large language models can do a lot of really useful things. And they sometimes show emergent behavior. And it seems like a lot of the research areas being solved or die, and especially for PhD students who are kind of in the middle of this, right? They have to redefine their directions and try to find something meaningful. So in my personal opinion, I also think this is a very bad time because when you rely on one engine, right, like the whole community rely on one engine, it's not a healthy environment. I mean, we are not democratizing research. When some research has become too luxury, it's really not good. So, for example, my group is paying about $40,000 every month just to be able to run experiments. So when I was a student, I remember that, so I live in New Jersey and I studied at NYU. I usually go home with this small subway pass train, and I usually just launch some experiment, while I was waiting for the train on my laptop. And when I arrive home, I can see some interesting results. I fully understand what's going on. And, every year in the ACL conference, we can see very different ideas and insightful thoughts. But nowadays, I don't see that anymore. So it's also kind of depressing. Yeah, so I just want to say that to being challenged by this, right, is actually a good thing. Sometimes we are kind of living a very comfortable zone and we need to be challenged. So two things. One is that I still think that the large language models cannot do a lot of things in principle. So for example, they hallucinate a lot. I think the previous talk about that, and have a lot of bias. And sometimes it's very assertive, but it's lying, right? And also more importantly, it cannot do self-learning, self-critic, or self-updating, correction, and no knowledge generalization capabilities. And also, NLP is not equal to NLG, right? So there are a lot of much more challenging, exciting problems out there. So I'm going to talk about a few examples. So for example, my core area, since I was undergrad student, I have been working on information projection. So this is a table from a very nice paper, not from my group, but from someone else. They try to compare the ChatGPT performance on many different IE tasks compared to SOTA that uses some small models like BERT. You can see that except the first one, which is entity typing. So given a phrase, you need to know it's a location, person, organization. All other tasks, ChatGPT is far behind SOTA, small model, right? So that means we are not losing our jobs yet, at least for this task. Okay, so the case study I would like to show today is called situation reporting generation. So the idea is that we want to understand a complex situation, such as COVID, or maybe Ukraine crisis, or the Hamas situation, and suppose the events are unfolding, and we want to take actions, right? So we want to give suggestions, make decisions. So we want to look at the whole situation and construct a very comprehensive report. So far, this kind of task is done manually, completely manually. So for example, this very nice website called Data Friendly Space, they are writing reports for like earthquake or maybe Ukraine crisis once every 2 weeks. So they spend a lot of time. Many people are volunteering. So they show you the timeline, the stats, and they keep updating the tables and so on. But these kind of reports are very, very incomplete, just because they don't have enough time to keep up to date. And also sometimes they are a little bit boring in the sense that they really don't tell you, what are the insights or what are the suggestions for decision makers. So our goal here is to be able to automate this. We want to automatically generate this kind of report so that they are timely, comprehensive, and have a more organized presentation information for strategically important questions. So the book so we call this a SmartBook. So this name came from a retired commander who was our transition partner, was advising our project. So the idea is that we want to have a book, and the book has multiple chapters. Each chapter will have a section. Each section represents a very important question. So for example, like what is the position of China on the Ukraine-Russia conflict? And then we want to extract all the claims from multimodal, multilingual news, and then do fact-checking, do factual error correction, and then do a summary. And every piece of information is grounded back into the original source. And we also do multiple data modality processing. So the information coming from image, video, speech, and text, and multiple languages. So of course, the most natural question nowadays is that can GPT-4 do this already, right? Or maybe if we, equip GPT with a Bing search, right? So it have access to the whole web just to do more fair comparison. Can GPT already do this? So we found that for most of these questions, GPT model tends to give us very fluent, but very short, very generic and boring answers. And they usually don't have most up-to-date information, and there's no evidence. So sometimes it just make up things. And usually it only shows information from English text only. So for the same question, if we ask our SmartBook system, it will give you very informative answers. For example, it's Russian positioning forces. It will tell you when they arrive and what they're going to do next. And what is the size of the force country involved in Ukraine. It will aggregate the knowledge and give you a summary about the information. And sometimes it's really important to understand the most up-to-date information. For example, what is status of efforts to secure the release of these 2 people? GPT plus Bing search will say, okay, and as a language model, I don't have most recent information, but however, I do know who these 2 people are. So they will give you the title and what they have been doing in the past. And in contrast, our framework would say, there are some ongoing efforts. For example, the US government is meeting Russian officials, and these are the current most up-to-date information we know about these 2 people. And also for decision makers, it's important to understand why, right? So if we ask questions like, why is this nuclear power plant a target for Russia? GPT model will say it's not a specific target for Russia. So it's basically lying, right? It's hallucinating information. And it will also give you a very assertive reason why they believe it's not a specific target. So all the evidence is made up. And in contrast, our system will say it is a target for Russia because of the following reasons, and they give you the original source, and you can check. And also, every piece of information in the claim and the summary is going through fact checking. We don't let the model generate any information if that piece cannot be grounded back into the source. Okay, so to construct this kind of system, we will need to look at how can we generate a report from a bunch of different diverse sources? And we want to ask a very critically important questions and then ground the answer back into the factual evidence. So to start with the first component, which is how can we generate questions automatically? So the reason we need to generate this automatically is because humans are not really good at this. So human generated questions are usually very vague, sometimes very complex to pass, and they have hard time to keep up to date. So a lot of questions often, become outdated. So for example, like what are the reports on the naval activity in the Black Sea is not really relevant anymore. And a lot of the questions, they require the system to do multi-hop reasoning and aggregation, which is currently lacking in our question answering framework. So the questions, can we automatically generate this kind of questions automatically? So we look at regular intervals. So basically update our questions once every 2 weeks, just to mimic how human analysts are doing. And we pick the most important events by clustering the news articles within a given time period automatically. And for every cluster, we'll generate a chapter name that summarizes what is the most important topic of this cluster. And then within that chapter, we then generate a question by using the headline generation technique. So given a set of documents, we want to generate important questions. And the controlled factor will include what is the most informative question, and is this a strategically important question? So that seems like a very doable thing, right? Like the whole framework is very doable. So once we have the question, we can then inject claims and do summarization. However, there are a lot of really, really challenging problems in this kind of task. The first one is that most of the existing information injection system or claim detection systems, they cannot generalize knowledge. So when they cannot generalize knowledge, they cannot predict what's going to happen tomorrow, right? But it's really important for us to know, based on the current situation, what might happen tomorrow. So, so this is the work that we have been doing under Talos, which was also directed by Ed a while ago. So I want to show this big picture about how can we complete knowledge life cycle. So Reza, I think, proposed a neurosymbolic framework earlier. So the idea is very similar here. We believe that large neural models, including large language model and the vision language model, they do have some implicit knowledge. And the question is, how can we explicitly probe and extract and generalize the knowledge and force the model to understand, this is generalizable knowledge, and you should take that explicit knowledge into account when you do prediction or generation. So we basically try to elicit the explicit knowledge first, and then localize it and augment the model using this additional explicit knowledge. And of course, we can borrow some domain-specific knowledge or situation-specific knowledge from external source, including those that ejected from unstructured data automatically. And then we augment that and patch the knowledge back to the model. So that's the whole idea. So the first challenge is how can we do knowledge generalization? So the case study I want to talk about here is called schema induction. I'm sorry if the some of you already heard some of the previous work we did. So because we have been working on this for 4 years, but I promise the method I'm going to show here is new. It's a paper published at MLP next week. So the idea is that we believe a lot of stories repeat themselves, right? And then if we teach the model how to look at the patterns, then the model will be able to predict what's going to happen in the future. So I see many of you are smiling, especially the Asian students. It's because you probably recognize what I want to talk about here. So I have been living in US for 20 years and I was in China 20 years. So I'm kind of having this reverse cultural shock whenever I go back to China. And I keep doing reflection, like what's going on with the sexism environment, right? It's becoming worse and worse. So one reason I found is that we have so many terrible books and movies and TV shows. So one example is this kind of TV show called CEO Boss Guy. I even don't know how to translate this into English properly, but I guess all of you who are laughing knows what I'm talking about. So there's always this kind of serious stories. They talk about guy from a really rich family, always went to Harvard when they were 15 years old, and they can speak many languages, 5 languages, more than 5 languages, and then they own a very big company, multi-million dollars, and they always bump into a very poor, average girl who might graduate from a school in the middle of nowhere in the elevator or in a restaurant or something. And then they have this romance love, and the girl had a wonderful career because of that, right? So it's a terrible story, but they always pick the most beautiful actors and actresses, and it's everywhere, in Chinese movies, Korean, Japanese movies. And I have been observing this kind of shows since like 20 years ago, and it's becoming more and more popular. And the other secondary story kind of category is the stories by Chung Yao. Actually, how many people still know Chung Yao? Okay, that's terrible because she's supposed to be out of date already, right? She was the author when I was a kid. So when I was in middle school, I was so addicted to her stories. So I always read her books, because my parents don't allow me to. So I kind of cover myself with a bed sheet. That's how I hurt my eyesight. So every single book from her was translated into some TV show, or her media coverage, TV coverage is like 70% or something at some point. My grandma was watching her movies again and again, repeatedly. So her books are always about 3 people, right? The husband, the wife, and the third woman. The third woman is always very nice, very beautiful, and the wife is always very evil and ugly. And of course, finally the third woman wins, right? And then I don't know what's the point of this kind of books, right? Except that she always picked the most beautiful actors and actresses, right? So if you ask a GPT to tell us the patterns, GPT model can actually give you very precise patterns, like this one is about tearful moments, family relationship, cultural, social content, suffering and sacrifice, and opposite attract, power dynamics. So this is a CEO boss guy kind of scenario. So if you imagine we gather this kind of knowledge and let the GPT model to write books mimicking Chung Yao, it probably can do better than her, right? It can maybe more creative because it can make up things, right? Following the patterns, and maybe the previous paper won't be able to tell this is generated by machine or by Chung Yao, right? So and then once we learn those patterns, the model will be able to organize narrative really precisely. So here are the 5 scenes. You probably can see the first one is a man lost memory. And then this is he met the girl, rich girl. And this one is he met the poor girl. And this one is the poor girl always is a very not smart and always mess up things, always cannot organize papers and so on. And then he, managed to save her. And this is the first time he showed up in the office. So based on your knowledge, for those people who are familiar with this movie, can you give me a temporal order of these 5 scenes? Which one would be the first? 5, yeah. And then following that, what happened? 4, yeah. And then 2, 3, 1, yeah, exactly. So that's very accurate. So you can do this perfectly, right? So to put this in a more serious scenario, so we have observed a lot of repetitive patterns also in our other tasks. For example, when we are during pandemic, I finally learned how to do cooking. So I observed that whenever you are doing dumpling, dim sum, or buns, you always follow 2 steps, right? Like you make the wrapper and then you make a filling. And the most creative thing is what are the ingredients you made in the thing. But it's very repetitive, and you can probably automate a lot of recipe generation. And similarly in scientific domain, which I will talk a little bit more tomorrow, is that you often observe a lot of repetitive procedures. Usually the chemistry students, they hide themselves in library for 1 or 2 hours, then they can make up their chemistry experiment procedure, but sometimes they often fail just because they don't have enough time to observe or read so many procedures in the literature, but machines can do that. So for example, before you do stirring, you always need to add things, right? And then before you do purifying, you have to filter things before you do purifying. And the only difference is you add different variables, different conditions, and then to make different chemical compounds. So okay, so based on all of that, I just want to do a quick test to make sure that we understand what is a schema. So here's a story about Boston Marathon in 2014. So someone purchased a high pressure cooker and materials for bomb making, and I have 2 unknown events. And then we observed that there was an explosion during marathon, and then police found the bomb, and then he was sentenced to death. So for the first 2 blanks, can you guess what might happen? Anyone wants to make a guess? Yes. Oh, he must have been in marathon, right? Otherwise, the bomb might just stay in his home. Yeah, that's great. Yeah. Anything else? He made the bomb. Yeah. Otherwise, it's just a high pressure cooker, right? How about the 3rd blank? Between the explosion and the police found the bomb, what might happen?
He escaped.
He escaped. Although later he was sentenced to death, so he might escape, but he must be arrested later, right? Yeah. Anything else? People died, people got injured, right? And how about the final 2 blanks before he was sentenced to death? Yes. So it has to go through some legal process, right? Yeah. So we know this because we have seen, unfortunately, a lot of really bad events in news articles, right? So we learn these patterns implicitly in our mind, and then when we read a story, we automatically fill in the blank. So that's what we need to do when we write a situation report, because we want to learn the schema, and then we will able to predict what must have happened in the past, what's going to happen tomorrow. So a schema is a predetermined sequence of actions that define well-known situations. So this is definition from 1975 paper by Shank and Eberson, but we try to extend this to a more hierarchical view. So for example, we have a civil unrest schema. We'll going to have multiple chapters, and each chapter will have multiple super events, and then super event will have a sub-event as a child node, and each event is also have a typical entity type attached to it. So each number here shows the same entity that's being shared by multiple events. For example, John is a common entity involved. And then they are connected through logical temporal causal relations so that we can use that to do prediction. So this is not a new area. This is an area that was first proposed by Nate Chambers in 2008. He was the first one to try to automate this schema induction work. So at that time, most of the work is basically showing that we can learn a linear chain, and other events are in partial order. So we try to extend this to hierarchical structure, right? Have logical relations. And also, most of the previous methods try to rely on information injection techniques. So that means, you need a very reliable, very high quality IE framework that's targeted for open domain, which unfortunately is not very mature yet. So most of the work is based on the graph construct from IE and then try to generalize patterns. So most of these schemas are for closed domain, right? But we really want to extend this to open domain. So as I said at the beginning, we believe that there's some implicit knowledge already hidden in the language models, right? So the question is, how can we probe them? How can we elicit this knowledge? If you just ask the GPT model, say, what is a schema for disease outbreak? They won't understand what you mean by schema, right? So we really need to teach the model step by step how to do this. So we try to decompose the task into 3 steps. The first one is about construct a skeleton. And the second one is, once we have the skeleton, can we expand the structure by adding more and more events? And then the third one is to verify relations, connections among the events. To do the first one, if you just ask questions like, can you tell me the chapters about disease outbreak? The model won't understand what you mean by chapter or super events. So it's like a model who have observed a lot of data, but it's a little bit dumb if you don't give enough hints. So we need to give the model enough hints. So the way we do it is to use in-content learning. Basically, we try to show these are the example passages we see from Wikipedia describing disease outbreak. For example, this is one paragraph talking about Spanish flu. This is one passage talking about COVID. And this one is one passage about maybe SARS. And then the model can look at these examples. And then we ask, what are the major events happening in these example passages? And then the model will be able to say, oh, there must be a contributory factor. There must be a disease outbreak. There must be something called investigation. And then we can continue to ask, during this major event, what must have happened during this time? Or can you list the major events between this a major event and that major event under this scenario? And then finally, we can ask, what is the event happen or before, after, or what is the cause, or what is the logical relation? But the problem is that most of these models have really bad understanding about time and number, this kind of basic knowledge. The reason is because a lot of data it observed doesn't really show the right temporal order. 1/3 of the order of the events in news articles, narrative order, correlate with the real temporal order. So the reason is because most news articles usually talk about the outcome before they talk about what happened. So if you ask a model directly, does A happen before B, it will usually give you a wrong answer. So what we did is we decided to break down the question again into asking the model, like, what is start time, end time, and the duration? And then the model will be really good at finding the answer from the content. And then we can use Allen's relation. How many people actually know what is Allen's relation? You guys are ed students, you should know it. Okay, a couple of you. So James Allen is a very famous person, pioneer, one of the NLP pioneers from University of Rochester. So he proposed this temporal relation, have a very nice logical order, and you can do inference using that. So basically, given a start time and end time duration, this Allen's relation template can give you the automatic answer about before and after. Yeah, so we use that. So this is just another example to show why it's important to go back to the old, fashioned symbolic knowledge and combine that with implicit knowledge from a large language model. So once we introduced the schemas, we did a series of experiments. First, we tried to look at the quality, doing some intrinsic evaluation. So we can see that compared to GPT dot, which is the we asked the GPT model to linearize the graph and try to induce the schema from the event graph automatically. So compared to that, we can see much better performance, especially for hierarchical event F-score. And then we also want to know whether this kind of schema is interpretable, because our ultimate goal is to be able to tell a story and do prediction. So what we did is we showed the schema to human assessors and asked them to manually reconstruct a story based on the schema. So they can write a paragraph. For example, we show schema from Chun Yao's book. We asked the student to write a story about, a new story based on the schema. So, and then we asked another group of assessors to look at the stories and then say, how relevant, how interesting, how informative, or how logically correct, and whether you can find it readable, this kind of metrics. So you can see, again, compared to the traditional methods, either use graph-only methods or large language model alone or without this incremental prompting, we can see that the performance is much better. Okay, so these are some examples about what we induced. So disease outbreak, we can see these logical relations, and under each chapter, we have these super events, and we also have this optional variable, shows whether this event is optional or not, or repeatable or not. Yeah, and then in the leaf node, which is the most atomic event in the leaf node, we also induce the patterns for the most typical entities attached to the event. For example, you can see a patient is being shared by quarantine and also die or funeral event. Okay, so now the question is why we're doing this, right? Why this is useful? So one practical use is that maybe we can use this to improve our information ingestion system, because ultimately, you do want to know what already happened. So as I showed at the beginning, this IE problem is really not the a solved problem, right? Because the ultimate goal is to be able to populate knowledge base from multiple documents. But most of the work is done on the sentence level or paragraph level. So typical IE system is done like this. So we encode every token using embedding. And then in the decoding, we try to see whether every token is a trigger word of event or it's an entity. And then we look at the relations between entities, look at whether the entity play a role in the event, right? So it's a sequence encoding and a graph decoding. And most of these frameworks lack of global knowledge just because they use local content word embedding only. But if you look at the schema, you can really decompose the schema into global constraints. For example, a target of attack usually is a victim, is more likely to be the victim compared to attacker. So what we can do is we can just encode this kind of constraints from the schema into the decoding process. For example, here in the sentence, we may have trouble to understand whether Campbell is a person or facility. But if we look at the schema, we know that this is a person that was involved in a fine event. So maybe this should be a person instead of facility, so we can push up the hypothesis during decoding. So surprisingly, this works really well, especially for relation injection. So relation injection is some task that I never understood. I never had a lot of passion for because I don't understand why it's so hard for machine. So it's basically looking at the two entities and try to classify relation. And most of the content is only one token or no token, right? So the state of the art before using schema was only about 45% F score. So the model will miss things like the relation between troop and Baghdad, right? Because if we read this sentence, clearly, this troop is located in Baghdad because it just entered Baghdad, right? But from the schema, we can clearly know there's a located relation after this event happened. So we simply add that into decoding, and we can significantly improve every component. And more importantly, because we did this for open domain, so now we are able to extend the scope of IE from 33 types of events, which is what we have been doing in the past 2 decades, to 3,465 types. So this is another paper we are going to present next week in details. But what we did here is we have constructed this ontology, which was also effort initiated by Ed a few years ago. And then we construct schema for all of the scenarios covering these 3,400 types. And then we use the schema to guide us to weak supervision. So basically, we look at resources like ProbBank. Hope you guys still know what is ProbBank, Freenet, and then some news corpus. And we automatically annotate some training sentences using our schema. And then we train the fine-grained event type detection model. And because the search scope is so big, so we cannot just do classification directly. So what we did is we break this task into 2 components. One is to do ranking to see which type is most likely to match the input sentence or paragraph. And then we do classification based on the candidates. Maybe you are able to narrow down the candidates into I don't know, 50 types from the first stage, and then do a second stage classification. And then we can also apply the schema to do prediction. So the idea is that we can take the event graph constructed from, let's say, today's news, which is incomplete. And then we compare that instance graph with our schema graph. And then we look at every node that's in the schema graph, but not in the instance graph, to see how likely this one should be predicted. So we follow two criteria. One is look at the neighbors of this event to see whether the neighbors already match the schema, or we look at how likely I can walk from this event to other events. If these two criteria are matched, then we decide to predict the event node. Okay, so now we have this beautiful prediction model. Then what we can do for analysts, right, for the situation report generation. We believe this is a really nice framework that we can do simulation. The reason is because when they are preparing, for example, to help the first aid workers to prepare for rescue or some event for a natural disaster, they usually need to ask them to read a lot of news articles, some structured simulation. So it needs a lot of time to train them. So what we do here is that we take the schema and we decide to let them decorate the schema. So basically they can say, I assume this next disease outbreak is somewhere, in a rural place in Africa or something 50 years later, and these are the constraints. And then we can instantiate the schema, and then we can automatically generate news articles or report automatically for them to read. Okay, so the idea is that we will first look at the schema and take the initial assumption from human users. So they might say, I suppose the death rate is low, but the situation is in a rural area. And then we will look at each node in the schema to see which one is likely to be instantiated or match the assumption. And then once we select the subset of nodes from the schema, we'll use that as condition to generate situation report. And from the situation report, we can generate a sequence of news timelines automatically. So for the first step, we will basically ask the model, say, based on this assumption, do you think this event is likely to happen or not likely to happen or not sure? And if the model says, I'm not sure, then we'll further ask what can make you more sure. What kind of assumption can you add to so that you are more confident? So that means the machine is helping human users to expand the assumption to make the situation more precise. And then we further ask the model to make up actors that might be involved in the situation. So it's like we are trying to take advantage of hallucination capability of large language models. And surprisingly, they can give you some really interesting story, but you often observe a lot of really bad bias. For example, if you look at the names that match the rural area, poor area, they follow some patterns on nationality, which is the bias, coming from the pre-training data. We can, again, let human correct this bias, and the human can also help instantiate these entities. And then we take this instantiated schema as our input to control the news and report generation. So finally, the predicted events will be put into this report. So this, for example, it will start from a paragraph based on human assumptions. And then for every node that's already instantiated schema, we'll generate a paragraph about the situation. So yeah, so that's about the knowledge generalization part. So I should say that this shows a use case that cannot be done by large language model alone, but it definitely benefit from the implicit knowledge hidden in large language models. And we believe that this kind of knowledge generalization capability is very important because it actually helps us to define some new directions. In the past, we cannot do event organization, event prediction. Now we can. And in the past, we can only do a few dozens of event types. Now we can do more than 3,000 types. So that's the first one. And the second one, I want to just briefly talk about multimodal because I think that's also very important. Especially because I think the problem is more challenging than GPT model alone. So how many people have already played with the GPT-4V? Only a few people. Okay, yeah. So that's popular than in US, because in US there are tons of people groups are just working on what GPT-4V cannot do, right? So GPT-4V cannot understand situation. So if I post a picture like this, the model will say, the typical large language innovation model will say, a soldier is feeding a baby to a dog. So the entity recognition is perfect, right? Because you recognize soldier, recognize baby and dog, but the relations and events involving this are completely messed up. Okay, and then if we ask a simpler question, things like, what is happening in this picture? Sometimes the model, like a blip model, will say the grass is eating the horse, right? So what's going on here? What we found is that all of these large vision language models have highly biased problem towards entity recognition in their pre-training data or in a fine-tuning stage, because most of the language vision techniques are applied to recognizing objects and entities. Very few data sets and efforts have been put into identifying actions or maybe the semantic roles these entities played in the events. So we show two examples here. One is that we asked the model to watch a video that shows a book is falling to the floor. And we asked the model to say, can you describe the scene? Is this about the book falling like a rock, or is it about book rising like a rock? And most of the times, the model will pick the rising like a rock. And in the second task, we asked the model to do the opposite. So basically, we give a caption, and we ask the model to guess which video describe the action. So the one option is the original video. The other one is we reverse the temporal order. So basically, we reverse playing the video, and the model again, prefer the wrong order, the reversed video. So this is depressing, because if you look at the performance, it's barely above random guess, right? So these are the blue one is about the first task. We try to ask the action and action antonym, and the second one is about the retrieving the best video. So you can see it's sometimes it's even worse than random. And in contrast, if you look at the object replacement or object recognition task, it's very high, right? Very good. So that's the situation. So what can we do? So we believe, again, we fully believe these models still understand implicit knowledge. It just needs some training. It's like some kid who are good at some particular task, but not good at others. So we need to do some special training to forcing them to pay attention to the new task, right? So the question is, how can we design some informative tasks to do that? Again, here we use the symbolic knowledge. So here we use WordNet, right? Sounds very old-fashioned, but we use WordNet to construct antonym for verbs. And then we construct two small probing tasks. One is to force the model to align the video and the action in the text. So kind of ignore a little bit about the entities, but pay special attention to the action. And then the second one is to force the model to pay attention to the temporal order of the event compared to the sentence. So very simple. We just added two special loss functions to pay attention to these two things. And of course, the other problem of this kind of implicit model compared to humans is that when they learn a new task, when they learn a new knowledge, they tend to forget about the old knowledge. So if we only force them to pay attention to these two new loss functions, they will perform poorly on entity recognition. So that's why we need something called a fusion model, right? Knowledge fuser. So we patch the model with these two new loss functions, and then we fuse them together with the original knowledge. Okay, so the first loss function is called the video action contrastive learning. So we basically construct some difficult examples, and we show the negative example by showing the antonym of the actions, and we force the model to align perfectly the video and the action verbs. So that's the first loss function, the blue box. And then we also encourage the model to learn the correct temporal ordering implied by the action text. So that's the second one. And then we fuse them with the original frozen model that's really good at entity recognition. Here, we just use a very lightweight perceiver-based module so that we don't harm the original loss function too much. So here is something that I think need a lot more work, just because that's not how humans learn knowledge. I mean, we usually protect our old knowledge, right, without being touched when we learn new knowledge. But currently, it's very hard to do that. Okay, thank you. Yeah. So after we do this patching and fusion, we're able to push up the performance of the action recognition and temporal ordering to much better performance, close to 90%. And we didn't really hurt the entity recognition too much. It's still, the gray bars are still decent. And then we applied this to other problems. For example, GPT-4V is terrible at identifying geometry information. So for example, if I ask like, what is the which one is straight line, it will say B is not a straight line. And if we ask like which one is longer, it will say B is longer. So it basically means that it's missing some fundamental perception capability of geometry. But of course, it's understandable because the model is not designed for doing this problem. However, these are small examples, cannot distinguish shapes, cannot compute volume. So what we did is we followed a similar idea. We construct a new benchmark to force the model explicitly learn geometry. So before you learn the degree of the angle, you need to understand what is the angle. And between before you compute the length, you need to understand what is the segment, what is the arrow, right? So we do curriculum learning, teach the model step by step, just like what we did for the action verbs. And then surprisingly, after you mixing up this new benchmark, new probing task with the original frozen model, it can already give you much better performance, right? So yeah, so you can see now the current model can understand most of the geometry problems. And then finally, just want to very briefly talk about the contradictory claims. So because we observe this a lot from the multiple sources. So this is the work we did with under Ed's advice and collaboration. So the idea is to detecting claim frames automatically from multiple sources, and then do misinformation detection based on the multimedia knowledge, multilingual knowledge graph we constructed. So for example, if the event about shooting in the caption is inconsistent with what we detect from the image, then we say that might be a misinformation. And then it's important to do this in a multilingual setting because a lot of local news is much more informative than English news. So we made some effort to significantly expand this to many languages by doing cross-lingual fact-checking. So the idea here is very simple, just use IR, but try to control the retrieval using claim detection. And then once we find some misinformation or incorrect claims, then we try to automatically correct the factual errors. So this is actually very related to what Gisela has been doing a long time ago from the workshop. So we kind of got inspired from your work. So we try to decompose the question into multiple decompose the claim into multiple questions. And for each question, we look at the multilingual source to retrieve the claims that supporting this sub-question. And then we recompose the new claim based on the multilingual evidence. And if that new claim is different from the original claim, then we correct the factual errors. So finally, we put this all together, we'll have the summary. So given the multiple claims, we then use that as a condition to generate a summary. And every piece of the information in the summary has to be grounded back to the claims. So you will see the citation for every piece in the summary in our book. And then we finally did some experiments. The first important question is how strategically important our automatic general question is. So we did some manual evaluation by analysts. So these are the not graduate students, these are the analysts working in Army and other government agencies. And then we compare our framework with the web search plus GPT model. So you can see analysts found that our results are much more coherent, relevant, and strategically important. And then we also show the generated section content. You can see the middle column, web search and the GPT usually make up a lot of incorrect information, like this red part is incorrect, and the blue ones are informative ones. So you can see our results much better. And then we show this, we deliver this report to analysts, ask them to edit until they are satisfied, right? So they can remove things, they can add things. Okay, so and we found that the blur and the rouge score for the reports before and after editing is really decent, and only about 2% of the content that they removed from our draft. So that means most of the information is accurate. They made most efforts on adding more detailed evidence. Yeah, so that's all I want to show today. So I just want to say that, again, this is sentence coming from the paper that actually this added sentence we put in our defining NLP background paper. We don't believe that the field is becoming very boring, right? I mean, you can see there are still so many challenges and unsolved problems. And we don't think that there's a existential, I mean, at least I don't think there's a existential risk. That's just not a wrong conversation to have. I think we should look at the positive side because it can help us do so many great things. And I think for us, it's really, we should look at the big picture, look at more ambitious, look at the new problems, because maybe these models shut down some tasks, but it also opens up some new avenues. So if you look at the, for example, the ChatGPT website, people are using this tool for many exciting problems. Like, I'm going to do a job interview with Microsoft model. What can I do? Like, give them my CV, or maybe I'm going to travel to Melbourne. What are the most exciting like check-in luggage? Come with me. Where should I shop my essentials? And or maybe things like I have this sequence of destinations. How can I optimize my travel plan? So these are all the problems that we didn't pay attention to when we were mainly working on modular problems, right? And we need to also work very closely with other fields. I think many speakers already talked about that, work closely with social science, natural science, computer vision, and there's a completely mature and old area about knowledge representation reasoning, right? So how can we closely work with them, and how can we work with HCI people? So I should say that there are also a lot of problems that machines are really bad at, humans are really good, right? So for example, about checking against background knowledge, common sense knowledge, and capture other perspectives. Like, for example, human is really creative at introducing novel information, and they know that audience might not understand something, they will introduce details. So overall, I think we need some deeper thinking about what's going on and try to understand what works and what does not. And more importantly, I really think that we should not stay as a second-class citizen. We need to have a collective effort to have a really academic-owned, real open source model, so that we can have 100% access to and fully understand what's going on. Right? So even for models like the Metas models, Lava, Llama, I mean, they're not fully transparent because they give you the parameters they trained, but they don't need to really release code for training, right? So if we stay like this, we have to pay for them, and then we all, if something happened to OpenAI, we won't be able to do a lot of experiments. We really need to change that situation. So I was talking to a lot of colleagues in the US, like if every professor donated 20 GPUs, and if we are able to share those, let's say from 100 universities in the whole universe, then we should be able to do something much better. Right. So I don't know how realistic that is, but that's really my dream in the next 5 years. I really want to achieve that. Yeah. Thank you, everyone. I want to just quickly, if I have time, I want to quickly just show a couple of demos. It's in my slides. I'll share my slides. So this is a book about Turkey, Syria earthquake. And you can, click these different chapters. And this is for Ukraine crisis, and this for so this is another one showing for the U.S. Secretary's visit to about diplomacy scenario. And I don't have time for this, but you can play with this, look at our claim detection. And we also have something more organized, like you can, human can input their assumptions, and then they can tune the detail level. Yeah. So yeah, I'll just end it here, and if I still have time, take questions. Yeah. Okay.
That was impressive. I feel like you've really answered all the questions.
Okay.
And talk about all that. Anyway, we have questions. Anyone questions? Just raise your hand. I'll pass the mic to you.
Hi, I'm Duke from UNSW. I guess I just want to ask a minor question. So you said like you clustered the news. So how do you cluster the news to?
Yeah, so that clustering component is very simple. We just use embedding for representation and use TF-IDF to identify most important information. And surprisingly, it works much better than most of the fancy other, like hierarchical clustering algorithms. Yeah.
Yeah, this is from Monash. I'm interested in actually how to define the appropriate abstract level for the given people. Do you introduce actually the manually and guideline, or want to automate it?
So we do a top-down method instead of bottom-up. So in the sense that we decide the scenario, right? So we always know the name for the scenario, disease outbreak, or or maybe international conflict. So starting from the most abstract level, and then we let the model to expand that abstract node to more detailed node, super event, and we ask further, under this super event, what kind of sub event you observe. So the model is really trying to decide when to stop in the leaf level. So basically, if the model cannot expand further to more detailed events, it will stop.
Yeah, do you think the model can automatically learn such information?
It's kind of doing that because given the examples and given the implicit knowledge it has, it will just say, I don't have more to expand automatically. Yeah.
Okay, thank you.
Yeah.
So I'm Jason, PhD student. So our research is about stories, so I'm really interested in your story schema stuff. So one question I want to ask is, do you think how we should balance this scheme and the creativity stuff? Because I know recently research is trying to generate the truth for the stories. So because the truth means it's unpredictable, right?
Yeah.
But the scheme is predictable.
Yeah.
So how do you balance it? And how do we decide if there should be a scheme or should be a twist? And yeah, the second question is, will people really appreciate creativity? Because like your example, like Chong Yao's story, because I know Chong Yao used to write her own story, she likes, but she says it's not that not sell. So she starts to write stories the public will like. And then it points to those stereotypes, like she only writes those kind of stories.
Yeah.
But it's kind of sad because it's probably not
Why
what
sad?
she really likes.
I don't care whether she likes it reading. So yeah.
Yes, the question is, if the general public just love those kind of stories, what's the point of making creativity stuff?
Because they're damaging his young generation's brains, like I went to this Japan's conference in July. Among 300 people, you only see 6 women, including myself. And then when I asked the men scientists there, they were like, if you do an NLP PhD as a woman, you cannot find a husband in Japan. Right? I mean, yeah, I mean, of course, you can go to other countries, but anyway. So to answer your second question, I was just joking when I say we can automate what she's doing. I think she should just fade away. I think we should just get rid of that whole series of books and movies. Seriously, very seriously, we need to let AI to create something much more informative, education, and much more unbiased, and have some real knowledge so that the young generation are not wasting their time when they're watching or reading those books. So that's the second question. For the first one, I think yeah, we can talk more offline, but actually there are a lot of people trying to build this kind of virtual society using the LMs with multiple persona. So what we found is, generally we found is when you force the model to do a role playing, for example, pretend you are a Harry Potter fan, then the model is able to localize the knowledge related to that topic much more precisely than general prompt. So then what you can do is that you can define a lot of different characters and personas, and then let this model talk to each other. So the models can do a collaboration among themselves. They can critique each other, they can verify each other, and then they can do partnership with a human, right? So yeah, and many people in the science field, which I will talk a little bit tomorrow, is that they're already doing that. They want to build a virtual AI lab, so you can have a AI advisor, student, technician work together. Yeah, so I think the creativity is not only about generation; it's really about how you let multiple agents interact and how this agent also interact with human. Yeah.
Thank you very much.
It is Mel. I'm also a PhD student here. So my question is, I think I really like the schemas for in these works. So, what do you think? Different people or different groups of people may have different types of schemas for the same task.
So
maybe sometimes
yeah.
based on their background, based on their interests.
Yeah, so I don't have a good answer for that, just because we never did any like inter-human annotated agreement for schema curation. So what we normally did is we present this automatic induced schema to human and ask them to curate. But I should say, in most cases, humans' decision on what events to add or maybe how the granularity of the events are quite consistent. Maybe because we are always looking at the newsworthy scenarios, so people kind of have shared knowledge about what is the generalizable pattern from new scenarios. Yeah.
You mentioned about the implicit knowledge. So please go up. My question is that you mentioned about the implicit knowledge of LLMs. So what is your opinion about having these RAG-based systems that we can improve their explicit knowledge instead of having the schemas of these LLMs by retrieval augmentation based tools? So this.
Wow, that's a very long conversation I will be very happy to have, because I do think that that's upper bound if we keep doing what we are doing in terms of knowledge editing. So there are many problems. One is that we will never be able to clean up the data by adding some retrieved knowledge from news or from external knowledge base. And second is it's really difficult to reach the ripple effect. So once you added some knowledge, like the examples other speakers showed about Obama's birthplace, so it's really difficult to locate the exact nodes or concept in the implicit knowledge which are related or might be affected. I don't think we have found a good mechanism for that yet. So I think most of the work is trying to assume that there are some subset of neurons and parameters are responsible for the out-of-date knowledge, but I'm not quite sure that hypothesis is actually valid. So we need more theoretical proof on that. And then if we can really make the model transparent, can we trace the reasoning and updating paths? I think that will solve the problem better, but I don't think any of the existing work can do that. Yeah, I don't know whether that answers your question. Yeah, thank you.
One more. Last time.
Thank you. I really enjoyed this. I think it's great. I think what I took away from this is your continued focus on saying, yeah, these LLMs and even older AI and BERT and those older ones, they have a lot of factual knowledge. But what's interesting to us as people is we put the facts together into higher structures. So if we're interested in temporal sequencing and even a bit of goal-related causality, and then we go to schemas, right? They give us a temporal schema. If we're interested in truth and support of truth and claims like this, then we go to claim frames, things like that. If we're interested in emotional highs and lows and relationships and things, then we go to stories and novels. So I sit here wondering, well, how many other major types of organization
Mm.
we have? I can think one, of course, is the experimental structure of an argument from a scientific paper.
Mm.
I have my belief, I have my claims, I have my method, I have my thing, I have my right.
Mm.
And so there is some work on doing that sort of structural analysis of these papers. So that's a different kind of animal.
Mm.
So I'm wondering, have you run into any completely different kinds of structures? What are the relationships that we use when we organize our knowledge into a higher level interpretive machine thing, right? What is not yet being addressed? Can you think of any? Have you run into any?
Yeah, so I can give two examples I think are relevant to what you said. So I think in many cases, we need to decouple the basic perception from reasoning and generalization. So in scientific domain, for example, for drug discovery, we really care which substructure of a molecule is corresponding to a function, you know, like a toxicity or blood-brain barrier. Currently, the model, large language model, you know, scientific domain knowledge aware large language model is just memorizing the sequences of content for the molecular string. It does not understand the patterns of, or maybe put this 10 molecular structure together. This is the substructure that's responsible for that knowledge. So I think if we ask the model, large language model, based on the current vanilla transformer design to do scientific discovery, it's going nowhere. That's my opinion. I mean, we can use the model to help us memorize the sentences, have some low-level association knowledge, but then to be able to build something new on top of that, we need a human to get involved, or we need some symbolic knowledge reasoning on top of that. Yeah, and also the for the vision problem, I think a lot of cases needs a separate skills. Like, for example, if we ask GPT-4V to read what's the time from the clock, usually, most cases it won't be able to do that, just because it's not how the transformer model, the self-attention mechanism is trained to do this that kind of task. So my opinion is that we need to teach the model like what we teach kids, you know, do curriculum learning step by step, make sure that every step do a quality control before moving to next step. It's kind of a really old-fashioned way for thinking problems. Yeah.
It's very, very so one is functionality.
Yeah.
One is visual presentation of temporal sequence, right? So there is probably a whole bunch more basic things that are so basic we don't even think about people. But these machines that just do word associations don't know. But if we start training them in the different directions of the assembly, we probably have a lot more powerful functionality.
Yeah.
Yeah.
Yeah. Thank you.
Let's give a last round of applause.
Yeah. Thank you very much.